Alright, 11-3, areas of regular polygons and circles. Students will be able to find the areas of regular polygons and circles. Alright, here's a deal. We're going to use this, learn this new term, so let me zoom in and write this new term for you. It is the apothem. And what the apothem is, it is the segment drawn from the center of a regular polygon and perpendicular to one of its sides. So let me draw this for you. Let's say that we have a hexagon. Let's just assume this is a regular hexagon. I know my drawing's not that great. And let's assume this is the center. The apothem would be this distance to one of these sides. And it would exist on one for every side. Okay? So one way you could think of it is kind of like a radius to a regular polygon, except for the radius in a circle exists at every point. Because it's a circle, it's always the same distance. The apothem is only going to go right to the side. And it's actually going to go right to the midpoint every single time. Okay, so that's the apothem. And the reason why we want to know what the apothem is because when we're trying to find the area of a regular polygon, we have this nice little formula, and it's area equals 1/2 the perimeter times the apothem. 1/2 perimeter times the apothem. Okay, so we're going to use this formula on a couple problems here, so let's go on to the next page. And take a look. We have a regular pentagon, meaning 5 sides, and it has a perimeter of 40. So let's just go ahead and mark that down. My perimeter equals 40 centimeters. Well, if I wanted to find the area, I would need the perimeter, and I would also need the apothem. But they don't give me anything about the apothem, so I need to figure it out. Well, it's actually not that hard to figure it out, because I know that if this is 5 sides, and it's a regular polygon, then each side is 8, because 40 divided by 5 is 8. And then, if I was to zoom in on this guy, we zoom in and we kind of draw a little center, and I could draw an apothem just like that, right? All these sides are 8, by the way. They're all 8. And if I wanted to, also, I could draw a whole bunch of little triangles here in the center. Right? And so, since a full rotation is 360 degrees, I could find the angle of just one of these triangles by taking 360 and dividing it by 5. And that would give me 72. And that would be the same thing here, and here, and here. And then here, I drew the apothem. And so that means that I cut this triangle in half. So instead of writing 72 for this whole thing, I'm going to just do half of it. Alright, so I'm going to write 36 right here. Okay, and remember also, I said that this whole side is 8. So that means that if I wanted to just do half this side, it would be 4. And so now what I can do is I can actually zoom in on just this one little triangle, or what sometimes you might want to do is redraw this triangle that you're focusing in on a little bit bigger somewhere else. So here, let's draw it right here, because it's really just a right triangle with a 36-degree angle and a side of 4. And remember, we drew this little guy as the apothem, so this would be my apothem there. So now what I'm trying to do is I want to try and figure out what the apothem is based on this angle measure and this side of 4. Well, this is going to go back a ways to like chapter 7, but we learned a long time ago a little trigonometry. And if we have an angle and a side, we can get another side and other angles, of course. So, from the angle of 36, I have an opposite and I have an adjacent. Opposite and adjacent. That's O and A, so I'm going to use TOA from SOHCAHTOA. So, let's set that up. That means that the tangent of 36 degrees equals the opposite, which is 4, over the adjacent, which is A. Okay, let's zoom in here so I can focus in on solving for A here. I'm going to multiply both sides by A. making these guys cancel. And I'm going to divide both sides by tangent 36, making these guys both cancel. And that leaves me with A equals 4 over tangent 36. Okay. Now, I could put this in my calculator and get a decimal answer and be done with it, with the apothem at least, but it would be a little bit better for me to just kind of leave that as is for now and go back to that formula that we just learned, which is area equals 1/2 perimeter times the apothem. And why don't I plug this information into that formula and then put everything into my calculator at once so I don't have to round a bunch of times. So let's do that. We'll zoom in. I know that the area should equal 1/2. My perimeter is 40. And my apothem, I found out, is actually 4 over tangent 36. I can plug all of that into my calculator. I can simplify a little bit first if I wanted to. Half of 40 is obviously 20 times 4 over tangent 36. And 20 times 4 is 80. So if I wanted to, I could just put 80 divided by tangent 36 in my calculator. And let's see what happens when I do that. 80 divided by tangent 36. I get, well, make sure that your calculator is in degree mode. I was just in radians. And you should get 110, excuse me, 110.11. Alright, 110.11. And remember, we were dealing with centimeters, so we're going to want to write that the area is in square centimeters. Now, if I would have found this value, rounded it, then plugged it in this formula, I would have gotten a slightly different answer. In fact, you would have gotten 110.2, which isn't bad, but it's not as accurate as the answer we came up with. So, when possible, you want to plug things into your calculator at the very last step. It just makes for a more accurate answer. Okay, so this next problem is a little tricky. I had most of you guys in class try this one on your own, but I'm just going to walk you guys through it from here. We're going to find the area of the regular hexagon, and notice it says exact. Whenever it says exact, that means I'm not going to use decimals. I'm going to use, like a pi, or I'm going to use the square root of 2 or the square root of 3. I'm not going to figure those out by decimals. I'm going to just leave it in terms of whatever I end up with. And I do know, I start off knowing what the apothem is. I know that the apothem is 8. So in order to get the area, I just need to find the perimeter. Well, let's zoom in and see what we could figure out here. Well, I have a center, probably about right there, with an apothem of 8. And now if I was to cut this thing into a bunch of triangles, I'd actually get 6 equilateral triangles. Or, yeah, because 360 divided by 6 triangles would make 60 degrees each. And they would all be 60 degrees, but we could just kind of fill that in. And since I cut this triangle in half by drawing the apothem, that means that this is a 30-degree angle, and this is a 30-degree angle, and this is a right angle. And so now I could zoom in. I want to know this distance out here, because if I can find that distance, I can multiply it by 2 to get one whole side, and then by 6 to get the whole perimeter, or just multiply it by 12 to get the whole perimeter. So I want to find just that distance. Well, if this is 30 and this is 90, this must be 60. And so now I have myself a 30, 60, 90 triangle. Now, I could use trig, but I know a shortcut. And that shortcut says that if I had a short leg, I can multiply it by rad 3 to get the longer leg. And I could just go backwards. If I have a longer leg, I could just divide it by rad 3. So x is going to equal 8 over rad 3. Well, I'm not really supposed to leave things with the radical underneath. But I am for just a second because I know that I can multiply this by 2 and then by 6 to get the perimeter. So in order to find the perimeter, I'm going to just multiply it by 12. So let's do that first. And 8 times 12 is 96. So you get perimeter equals 96 over rad 3. And now let's go ahead and rationalize it. Rad 3 over rad 3. And what you get on top is 96 rad 3. And you get a 3 on the bottom. And 96 divided by 3 is simply 32. So for your perimeter, you have 32 rad 3. Now remember, they wanted an exact answer, so I'm just leaving it like that. I'm not going to try and figure out a decimal. And now I'm going to figure out the actual area. Area equals 1/2 that perimeter that we just found, which is 32 rad 3, times the apothem, which we found was 8. And let's just work this through. 1/2 of 32 is 16. So we got 16 rad 3 times 8. And 16 times 8 is 128. There we go. And they didn't give us units, so we're just going to write units squared. 128 rad 3 units squared. We just leave it like that. We don't need a decimal. We just leave it in that form because that is the most exact way to leave it. Okay. Let's do this next little exercise. It says if you treat a circle as a regular polygon, what would be the perimeter and what would be the apothem? Well, the apothem would be like the radius, and the perimeter would be like the circumference, which equals 2 pi r. And so if we wanted to fill in this equation using circle terms, we would just say A equals 1/2. The perimeter is 2 pi r, and the apothem is just like the radius. Well, 1/2 times 2 is just 1, so those guys kind of just cancel each other out. So we're just left with pi r times r, which is the same thing as pi r squared. And this is a formula that you should have seen before. Area equals pi r squared. Look at that. So it's kind of where we could say we get that formula. So let's do this. Got a problem here. It says a caterer has a 48-inch diameter table that is 34 inches tall. She wants a tablecloth. I guess that little 2 there is a typo. She wants a tablecloth that will touch the floor. Find the area of the tablecloth. Well, that's easy because we have this little formula, so all we really need is the radius. But they don't really give us the radius here. They tell us this distance across is 48 and this distance here is 34. The radius would be from the center out. So it would be half of 48, which is 24, plus 34, which is 58 inches. That's my radius. Okay. Well, let's just plug that in. Area equals pi 58 squared. And 58 squared is 3364. So area equals 3364 pi inches squared. And we could just leave it in terms of pi. We don't have to multiply it by pi and get some weird decimal. But if they did ask you to, if they asked you to round to a near decimal, you could by just plugging in your calculator and multiplying it by pi, and you'd get something like area equals 10568.32 inches squared. And that answer works as well, but I like to just stop here as long as they don't tell me to round to a decimal, because that's an exact answer and it's just a little bit easier to get to. So I'm done. Alright, let's go on to the next page. Alright, this one says find the area of the shaded region, assume the triangle is equilateral, and that the circle has a radius of 4 meters. I guess that's another little typo that I didn't notice before. Don't need that yet. But the circle has a radius of 4. Well, first thing I'm going to do is, how am I going to find the shaded area? Well, I know that the area of the circle minus the area of the triangle should equal the shaded area, right? If I can take the circle area and then subtract out this triangle, I'd get the shaded area. So how would I do that? Well, I know the area formula for a circle, so that should be easy, especially since I have the radius. So let's do that first. The area of the circle is just going to be pi r squared, and the r in this situation is 4. And 4 squared is 16, so this is just 16 pi meters squared. Alright, so we got the area of the circle. Now we need to find the area of the triangle. We have the skills to do this, so let's zoom in and see what we can figure out. Well, a little tricky at first, because you're thinking like, well, all I know is the radius, and that doesn't really help me, except when I draw the radius at certain parts. If I draw the radius here, suddenly that can help me quite a bit, because I know this is an equilateral triangle, so I know all these angles are 60. And then if I was to kind of just split this guy down, I know this would be a right angle. And if this angle was 60 and I split it right in half at the radius, that would make this 30, this 90, and this 60. Well, that's a 30, 60, 90 triangle. So I know some tricks for that. If I have the hypotenuse, I know the shorter leg is half the hypotenuse of 2. And I know that the longer leg is going to be the shorter leg times rad 3. And so this is also going to be 2 rad 3, which means that the total base is 4 rad 3. And I can also draw in this other radius here, which I know is 4, which tells me that my whole base is 6. Alright, well now I have enough information to calculate the area of the triangle. So area of the triangle equals 1/2 my base, which we found was 4 rad 3, my height, which we found was 6, and I can just multiply this through. 1/2 of 4 is 2, and 2 times 6 is 12, so area of the triangle is 12 rad 3. And so I said at the beginning that I would need to do area of the circle minus area of the triangle to get the shaded area. So let's just do that. The circle was 16 pi, and the triangle was 12 rad 3. Let's just plug that into our calculators. Well, actually, before we do that, let me just say that that answer is actually fine. We could just leave it like this and say, hey, that's meters squared. But let's say they wanted this rounded to a decimal, we'd have to actually plug it into our calculators then. And we would get something along the lines of 29.48 meters squared. And so that would be the answer in decimal form. Alright, you guys, last problem here. I want you to find the area of the shaded region in terms of R. If the shaded region is represented by a regular hexagon inscribed by a circle with radius r units. So now they're not giving us a number, they're just giving us a letter r, and we're going to use that for the radius. And we actually can use it for the apothem too. So you're going to need to find the perimeter of the hexagon, find the area of the hexagon, subtract the area of the circle, and leave it all in terms of r. So just using variables, but it's something you guys are capable of doing. So, alright, I'll see you guys on the next video.